What is up, team? I am the Master's Math Teacher. So now we've looked at the language of polynomials, let's look at some questions involving this. So jump on board and let's get into it. So the first question we might get presented when dealing with polynomials is using substitution of information to find missing variables. So let's look at that. So we've got an example here, which is p of x equals 4x cubed plus ax squared plus bx plus 6. Now currently, we have two missing variables. We have a and we have b. Now we obviously have x as an unknown. However, because this is a polynomial in terms of x, that x is fine to stay there. So the two that we want to find is a and b. So if we want to find two unknowns, we need two bits of information. So let's give you p of 1 equals p of 2 equals 0. Okay, so this is the sort of question you might get presented with. Now, what this means is we've got two equations here. P of 1 equals 0 and p of 2 equals 0. Now the reason I've written these in two different colors is so that we could distinguish them when we substitute the values. So let's do our blue one first. We've got p of 1. Now, remember when we substitute that value in, all we have to do is replace x with 1. So we got 4 times 1 cubed plus a times 1 squared plus b times 1 plus 6. And if we expand that out, so we've got 1 cubed is 1, 4 times 1 is just 4, 1 squared here is going to be 1 as well, a times 1, just a, then we got b times 1 is b, and we got 6. Now let's just group the constants here to make this a little bit nicer. And we're going to get 10 plus a plus b, and that all has to equal 0 because of our piece of information. We knew that p of 1 equals 0. Let's look at our second bit of information, p of 2. So again, we substitute the 2 wherever there's an x. So we got 4 times 2 cubed plus a times 2 squared plus b times 2 plus 6. 2 cubed we know is 8, so we got 4 times 8 is 2 times 2 is 4 times 2 again, that's 8. 2 squared is 4, so we got 4a here. Then we got 2 times b is 2b, and we got plus 6. Now note that I'm writing the number in front of the letter here, so 4a rather than a4. That's just a mathematical convention, and it's a really good habit to get into. Then 4 times 8, we've got 32, plus 4a, plus 2b, plus 6. And again, let's just group the like terms here so that we have a little bit more of a nice equation. So we've got 38 plus 4a plus 2b, and of course this also equals 0 based on our information here. So what I'm going to do is I'm going to write both of these on top of each other so that we can see what we should do next. So I'm going to pull up my blue and I'm going to go with my 10 plus a plus b equals 0, and my green 38 plus 4a plus 2b equals 0. So now we have two bits of information here. We need to eliminate one of these variables in order to solve this. So what we're doing here is we're actually doing simultaneous equations. Now you might remember doing simultaneous equations earlier in the year. So what we have to do is either the substitution method or the elimination method. Both ways work. However, for this example, I'm going to use the elimination method because it's going to work out a little bit easier here. So to eliminate, I notice that the b I only have to times by 2. I could eliminate the a by timesing by 4. However, timesing by 2 is a little bit easier than timesing by 4. I'm going to times this whole equation by 2. So we're going to end up getting 20 plus 2a, 2b equals, and 0 times 2, 0. Okay, the reason we did that is now we have the same amount of b's. So we can take the first equation from the second equation. So let's call this equation 2. We'll call our green one equation 1. And we're going to do equation 1 minus equation 2. So let's do that. So 38 minus 20, we're going to get 18. Then 4a minus 2a, we're going to get 2a's. 2b minus 2b is 0. That's the whole purpose. That's what we were doing with the elimination method, is getting rid of that b. And that still equals 0, because 0 takes 0 is still 0. So now we've got a nice little equation here in terms of just one missing variable. So we get to solve that. So we're going to take the 18 from both sides. So we got 2a equals negative 18, and then divide by the 2. So we get a equals negative 9. Now we've got one of the missing variables. How do you think we find the other missing variable? And sure enough, we just sub it into one of the equations. Now I'm going to sub it back in to our first blue one, because that's our nicest one here. So I'm going to go 10 plus negative 9 plus b equals 0. 10 plus negative 9, it's the same as saying 10 minus 9. So we've got 1 plus b equals 0. Take 1, and we get b equals negative 1. So now we have both of the missing variables. To finish up this question, we just like to write it a little neater, and we just write our p of x, and we write out the full equation for p of x using our new values for a and b. We go p of x equals 4x cubed. Now we've got plus negative 9x. So that's the same as just saying 9. So 9x squared. Then look back at our b. Our b was negative 1. So we're going to go minus 1 x plus 6. Okay, and we don't have to write 1 here, do we? We always just write negative x. So this is our polynomial. It was the same polynomial we started with, but given the 2 bits of information, we were able to find what is a and what is b. Now this question only had 2 missing variables. This can apply for any amount of missing variables. It could be 1, 2, 3. It could be any amount. It could even go up to 10. However, for this course, you will more likely than not only be dealing with 1 to 3 missing variables. Once it gets further than that, you would likely use your CAS to solve this sort of question. The next cool thing we can do with polynomials is perform operations on them. And what I mean by that is we can multiply them, divide them, add them, and subtract them from each other. So if I said p of x equals 3x squared plus 2x plus 4, and I said that q of x equals x minus 2, I can actually ask what is p of x minus q of x. And so all we have to do here is write it out. So 3x squared plus 2x plus 4, and we're going to minus all of q of x. So when we do that, I'll write in black now that we've got our answer. We're going to go with 3x squared plus 2x plus 4 minus x plus 2. So notice I'm expanding that negative in. So we're going to minus x, then plus 2, because negative, negative equals positive. Then we just group the like terms. So I'll circle the x's. I'm going to square the constants. They're the things we're adding together. So we're going to go with 3x squared, because there was no other x squared terms. The x terms, we got 2x minus x is going to be 1x. And we've got 4 plus 2. We got plus 6. So this is p of x minus q of x. We can also multiply them. So if I did p of x times q of x. Now that little dot just means times. I just don't want to confuse you with writing more x's here. So let's multiply them. Again, I'm going to write my p of x first. 2x plus 4. Now when we're multiplying, make sure to put them all in brackets. When we're adding and subtracting, it didn't matter as much. It matters for the second one, of course, because we're taking away the whole thing. But with multiplication, it's best to put brackets around both. Otherwise, you will accidentally make a mistake. So, right now, this kind of looks like something we can do, but we can write that the other way around to make it something we've done multiple times in the past. 3x squared 2x plus 4. So I haven't changed the question. I've just rearranged. Remember, we're allowed to do that. Now, we can expand. So I'm going x times 3x squared, and that is 3x cubed. I'm going with x times 2x, so we got 2x squared. And I'm going with x times 4 is 4x. Now I'm going to go with negative 2 times 3x squared. That's going to be negative 6x squared. Negative 2 times positive 2x. We're going to go with negative 4x. And negative 2 times positive 4. That's negative 8. Now again, we group the like terms. There's no x cubed terms, so that's all by itself. The x squared terms I'm going to underline here. We've got 2x squared minus 6x squared. That's going to yield negative 4x squared. Now let's look at our x terms. We've got 4x and we've got minus 4x. Well, that actually equals 0. So we're not going to write that at all. And then we've got our lonely little negative 8 out the back with no x's. Okay, so this is how we multiply, add, and subtract polynomials from each other. Now, adding is the exact same as minusing. It's just going to be the addition symbol instead. Now, we can also do division. However, it's a lot more complex. And so what we're going to do is actually do that in a whole separate video, because there's a whole section revolving around how to divide polynomials. It's a bit more complex than this. And the final thing I want to explore here, and that's called equating coefficients. I'm actually going to write that up here. Equating coefficients. So what that means is if we set two polynomials equal to each other, their coefficients must be the exact same. So let's take a look at this example here. We've got p of x equals 4x cubed. Take 9x squared plus 2x plus 3. And I'm going to go with q of x equals ax4 plus bx cubed plus cx squared plus dx plus e. So what we have to do here, we're equating the coefficients. If I said p of x equals q of x, okay, if I said that they were the same thing, so we equate the coefficients. First, let's look at our x4 term. Well, hold on a minute, there's no x4 term in P of x. So that means that A has to equal 0. Okay? Because they have to be the same. They have to be the same amount of x4s in both Px and Qx. But there is exactly 0 in P of x. So that means that A has to equal 0 for there to be the same amount. Okay, let's look at the next one. We've got 4x cubes on P of x and bx cubes in Q of x. Well, that means that 4 equals b. We're just saying the coefficient in front of the x cubed has to be the same. All right, let's look at the next one. From a different color again. We're looking at our x squared term. So there's negative 9x squareds on P of x, and there's cx squareds in Q of x. So sure enough, that means that negative 9 equals c. They must be the exact same. That's what equating coefficients is all about. So I want you to give it a shot, pause the video, and see if you can tell me what d and e are. Okay, so for d of x, let's have a look. We got 2x's here, and dx is here. So sure enough, 2 equals d. And finally, we've got our constant, e, and 3. They also have to equal the exact same thing. For this to be the exact same polynomial, everything must be the same. So we know that 3 equals e. Okay, so this was one where they were just straight up easily able to be identified. What if we look at something a tiny bit more complex? I'm going to scroll down so that we block this out a little bit. We're looking at a new P of x. P of x equals x cubed plus 3x squared plus 2x plus 1. Now the question has said that this can be written as x minus 2 brackets x squared plus bx plus c with a plus r out the back. Okay, so it's said that they can be written as that. So that means that P of x equals this whole thing. X minus 2, x squared plus bx plus c with a plus r out the back. Now currently we actually cannot just equate the coefficients yet, because this doesn't have, it's not in the exact same form as our P of x was. So what we have to do first is expand it. So x times x squared, x cubed. X times bx is bx squared. X times c is cx. Now we look at our negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times bx is negative 2bx. And negative 2 times c is negative 2c. And we still have our little r out the back. It was not in the brackets, so we didn't expand it. Now there's one more thing we have to do again before we equate the coefficients. And that's group the like terms here. So what we're going to do, we're going to look at the x cubes. There's only one x cubed, so that's fine. X cubed is by itself. What about our x squareds? We've got bx squared, take 2x squared. Now obviously we don't know what b take 2 is. However, what we can do is we can say b minus 2 is the coefficient in front of x squared. So we're essentially factoring out x squared from these two terms. Okay, and sure enough, if you expand that, b times x squared bx squared, negative 2 times x squared, negative 2x squared. So this is the exact same thing. We're just grouping that up so that we can equate our coefficients in the next step. So we're going to do the same thing with our x's. We've got plus c and minus 2b. Again, we can't do that in our head. C minus 2b, we don't know what they are, so we can't solve that. But we can factor out the x and write c minus 2b is our coefficient of x. Then we can just write our 2c plus r. And if you'd like, you can actually put this in brackets as well, because that's going to be our constant term. Now we get to play connect the points. So we're looking at equating the coefficients. So I'm going to write these next to each other here. I'm going to write p of x and what it equals. So I'm going to go with x squared plus 3x squared, x cubed, plus 3x squared plus 2x plus 1 equals x cubed plus b minus 2 x squared plus c minus 2b x plus negative 2c plus r. Alright, let's equate coefficients. So let's look at our x cubed term. There's 1x cubed here and 1x cubed here. Good. Don't have to worry about it. There is no missing variable there, so it's all good. And 1 equals 1. Good, we're fine. Let's look at our next one. Our x squared term. We have 3x squareds here and b minus 2 x squareds on the other side. So what we have to do to equate the coefficients, we know that the 3 has to equal the b minus 2. Okay, and what we can do now is actually just solve this for b by adding the 2 over. So b equals 5. Okay, that's our first bit that we can find. So we always work it out, slowly but steadily. Our next one, we're going to look at our x. So we've got 2x, and we've got c minus 2bx. So again, 2 equals c minus 2b. Hold on. There is 2 variables here. Pause the video and see if you can figure out what we should do. Okay, so we have 2 missing variables, but we actually just found out what b is. So we can substitute that in so that we can find our c. So 2 equals c, take 2 times 5. So 2 equals c, take 10. Then we can solve it. Plus 10, plus 10. So c equals 12. Okay, so fortunately, we actually got given this question in a nice order because we found b first, then c second, and now we're going to find the other letter. If this is not the case, it might be worth writing out all the different top lines. So the 3 equals b minus 2 first, then your 2 equals c minus 2b, then your third one, and figuring out which one can you solve first. Okay. Fortunately for this example, we didn't have to do that. We can just work it forwards and it's all good. So our final one is our constant. So plus 1 and plus negative 2c plus r. So again, we've got 1 equals negative 2c plus r. Again, pause the video and see if you can solve this one. Okay, so we have 1 equals negative 2 times 12 plus r. 1 equals negative 24 plus r. Adding the 24 over, we get r equals 25. Okay, so what we've done, we expanded what we knew it equaled, and then we equated the coefficients. So now what we can actually say is, going back to our original black color, we can say that P of x can be written as x take 2 x squared plus 5x plus 12 with a plus 25 out the back. That is what we've found out. And that's actually how we factor P of x. So if we took out x minus 2 as a factor, this is what we would get as our answer. And we'll explore that in later chapters. So this is called equating coefficients. Alright, so now you have all the skills required to tackle questions involving the use of polynomials. I'd wish you luck, but I know you don't need it. So go smash out some mathematics. And as always, if you like this video, give it a like. If you didn't, give it a dislike. And let me know in the comments what I can do better. If you have a topic you want me to cover, let me know in the comments below.